Okay, I think I'm set to look. So, I have one, well, at least for now, I have at least one last circuit board to work on. And that is this main control board that can control the LCD display. Maxing out all the I/O, my goodness. Oh no, I just realized a problem. I have power control for RFID over here. And I have a pull. Oh, no, never mind. So, this is a P channel FET. So it needs to pull up on the input to the FET to turn it off, pull it to ground to turn it on. But the enable pin, I want to pull it to ground when this is off. So it's correct. But let's go and annotate this schematic. And I'm fully suspecting that I've forgotten some footprints. So let's see. Probably need to change out these inductors. It's probably not going to import them. Let's see here. F8. It's going to load. There. Yep. J5, J6, and a couple jumpos. Yeah. So it didn't input those. So let's open another version. J5 and J6. That's J4 at J5. No. We're using this one. And J6 is the same one. Just realizing something. The base station, which is open on my other screen here. No, it's the printer one I'm thinking of. I think I put the wrong connector down. Initially thought the connector was a 2.5, but it's actually 2.54 millimeter pitch connector. So let's just double check this. It does not have a 2.54 connector. It's 2.5. Nothing that's 2.54. Should work. Let's just move this over here, and I'm gonna fix that footprint. This is this one over here. Update. So the pins are backwards on this. The plan is to do the main control board, but I realized this connector for the printer power is wrong. The one I was using before was a 2.5 millimeter pitch, and it's supposed to be 2.54. So I'm trying to update it. But the pin count is backwards between the two. So I'm gonna have to do some copy and pasting. And I want the better silk screen. So I'm gonna copy that. I'm gonna update it and change it. I also finished the base station from the other night. Didn't take me too long. Once I replaced my mouse, I ended up opening up my old one to figure out what the heck was going wrong with it. And the button inside lost all its spring power, so it was pretty much almost always pressed. I always double check the pinout when changing a connector. Yeah, should be finishing up the MCU board today, and then I've got 2 of 3 of the bill of materials done. Need the pins. What in the world? that's fixed. Right. Save. And let's see if I got all the parts for this fixed. No. Not found for symbol U1, pin 21. U2. I see. U1. Secure fan. 21. Ah, it's ground. Change it to pin 20. Oh, sorry, pin 17. There, ties it to ground. Bring in the two missing parts, and I believe there were two jumpers that I haven't set. Where is it? There's one here. This one is supposed to be partially connected, if I'm not mistaken. Fruit. I think this one is a partly connected one. I'm looking at the I'm looking at the wrong item. Should be the right one, yeah, momentary. That way you put your finger on it, sends a pulse that your finger is on it, move the finger, pulse turns off. Momentary. Yeah. So they're connecting across to power. Attempted to do that manually, having to cut that track and do it again to change it. It's going to be a little annoying, especially because this board is going to be tight. It's going to be easier to just solder it. That, and it's painfully obvious when you have solder on it, which mode it's in. Actually, using the numbered pads wouldn't be a bad idea in this case. And then there should be one other jumper somewhere. Wait, which number is that? Yeah, jump at 1. There should be one other one. There it is. There we go. And just check. Yeah, no errors. Cool. So all those parts have to fit onto a circuit board. So the fun part is going to be tracing out the circuit board. So I have to pretty much follow this circuit board. Interestingly enough, it's got these notches that lock into some plastic tabs here, which will be kind of useful, I think. But what I have to do is, obviously I have to keep the connector for the screen pretty much centered where it is. My only grace is that I can extend the board in this direction, because it will sit in the barcode scanner like this. So this would be the bottom of the screen and this would be the top. But I ideally don't want it to be like all the way out this way. I need it to be as small as I can get it. So but let's figure out the sizing for this circuit board. Man, I built myself a nice big custom desk and I still don't have enough space. I really need to organize things a bit more. Wait, how thick is this circuit board? Oh no, that's a 1mm board. Darn. No, it's a 1.2mm board. Is that gonna fit a 1.6 or am I gonna be stuck using a 1.2? Although it looks like they aren't upcharging on the 1.2. Or the 1. Do they not upcharge on these? Wow. Can't get purple in the 0.8, which is good to know. So I could get it in 1.2. Yeah, that's what I'm wondering, is if I use the slotting on this, I'm probably gonna have to keep the sizing. But it's actually a 1.2 millimeter. It was reading 1.5 before, but yeah, it's reading 1.5. And I'd imagine tolerance-wise that that's gonna actually be a 1.2 millimeter board. Does it have? Yeah, it's got some slop to it, so a 1.2 will fit. What I wanted to try and find. This is 1.6. Oh, 1.6 will fit. Yeah. It's a little snug, but it will fit. But if they're not going to upcharge for the 1.2, and I can get it in a 4-layer board, then probably do that. Oh. Don't need to put that away yet. I still need to measure things. So it's 46 millimeters wide. So, .46 millimeters. One 1.3 at the moment. And then the other critical dimension will be these notches. Looks like it's coming in at about 41.4. In which case I'm going to want to change the grid size. Actually, I'm gonna yeah, no worries, Dodgy. Having fun in the shed? And $3 millimeters. Yeah, 41.4 is what I ended up doing. That's how long the... Oh. Did I go to 0.3? No, 41.4. Did you end up looking at that YouTube channel? The robotics one? James Boughton? Yeah. 41.4. Mm. 3mm. .6. Yeah. Ooh, you got yourself a CNC, do ya? I wish I had a multi-axis mill. It'd be very handy for my trike project. Probably end up ordering some parts custom made for it at some point. But I'm a long ways away to doing that. If I had the money, I'd buy the Lumen PNP to do for this project, but it's expensive. Well, everything's expensive these days. Oof. Oh, a new trike? Yeah, my last trike cost me about 10K. Except now I'm gonna... oh, nice. I don't really have the space. Well, I have partial space, but... I tend to buy tools when I absolutely need them. Like my 3D printer, I bought that exactly when I needed it for a project, and I budgeted in the project. The big tool for this project that I'll end up buying is I'm buying a TIG welder, but I'm buying an aluminum TIG welder. And that will help me with my trike and help me with the ATM machine I have to build. Now, if I make that 100mm, how far out does that get me? Kinda curious. I have a feeling even at 100mm it's gonna be a little larger than I want. Oh no, that's not bad. That only puts it out a few millimeters past the screen. Yeah, I can live with that. Yeah, that'll be fine. Actually, with it being out this far, what I could even do is I could even add mount holes through the board to hold the light sensor that I want to put on it. I'm just going to put a quick connect light sensor in place. My next trike will be expensive, but not bad. Yeah, I have the MK2 pusher printer, and it's been a workhorse. I know a lot of printers are chasing print time these days, but I don't run a print farm, and I haven't needed to actually print stuff at absurd speeds to get it done in an hour. So I've been fine using it. If they did an IDEX one or something with built-in multi-material, I'd be interested, but the only one they're doing that on so far is the XL, and that thing is absolutely massive. Yeah, battery prices are getting pretty good these days. My current battery on my trike cost me about $4,000. I found a new company now making a battery that's better performing than the one I had initially built. No, that's right. And it's about $1,000 less. So I'm hoping to use it in my next one, but the weight requirements have changed for e-bikes in my area, rather annoyingly. So I have to watch it, and I want to build a full canopy on mine to protect it from weather, because the cold and the rain absolutely suck driving in, even with heated gear. And I plan to do it with aluminum and carbon fiber. And I'm highly considering making it a two-seater. Tandem. Two-seater. I always get asked, like, oh, what's it like driving it? Or somebody will actually try to push their luck and ask to drive it. And it's like, I have a hot-rodded motor on it. And it's fast. And it's also very expensive, so just letting anyone drive it. I think at most I let like 2 or 3 people try it, but those are people I absolutely trust. So having a second seat would be nice. Plus, with the second seat, gives me added cargo space, so I could even do food delivery stuff for people, which can give me a little spending cash. And considering I like driving, be a good way to spend some time. In 2 seats, I 2 years, 2.5, 7,000 kilometers on an e-bike, so it's pretty darn good. The only reason it wasn't more was because the battery crapped out on me. And that was my own fault with how I built it. I trust most people, usually. But I have a weird knack for meeting people in person and just having a gut feeling of like, yes, this can work, or no, this can't work. And I've never been wrong. Yeah, actually, where is it? Oh, the weather's not bad. It just, obviously we got the 4 seasons and goes from -20 to +30 throughout the year. Right now it's rainy season. Easily 15 millimeters a day. . The ground is absolutely soaked now. Absolute mush. Not much snow this year though. I think I put about 4 hours on my snowblower. For me, I'm easy to give trust, but once you lose it, you're almost never gonna regain it. Absolutely never. Plus, I'm a highly analytical person and logical thinker. So, the emotional ploy that people tend to play after the fact never works. I know it's a cold way of thinking / being, but can't entirely change who you are as a person. And it's better to accept yourself than to agonize over it. Oh wait, I'm just opening up. This is my trick. Here's the other one. I am on the spectrum. Here's the other photo of the trike. So, yeah. This thing was great. I loved it. This control panel on the right was what controls all the amber strobe lights, which work flawlessly. The only problem is I found it a lot harder half the time if I needed to push a button to turn something on. It's a lot harder to take your hands off the control sometimes. I also prefer these switches more. These are for the main control, lights, parking brake, reverse, headlights, high beams, and turn signals. And then I modified, these are white marine toggle switches, but I modified them with neopixels in them, which is very handy actually. So you can see them in the dark, and I did the same for the indicators. I modified them with neopixels in them. These are a lot nicer to reach for because you can really feel them and know where they are. They even have dimples on them, which I could actually feel through my normal mechanics gloves. So the headlights are actually custom. So I bought the projector housings from a company that sells retrofit kits. I bought their like bottom of the barrel $20 ones. Like, I mean bottom of the barrel, but they surprisingly produce a really crisp cutoff line. And now you're not normally supposed to be running LED headlights for these types of things, at least not on a car. They're not the most ideal, to be honest. They work, but not the most ideal. You really should use the Xeon bulbs that they normally sell you with them. But I did put just LED bulbs in these. And the reason I made these was because I've had in the past using like even really good bike headlights. You hit 40-50 kilometers an hour on a downhill and you'll actually outrun your lights. You can see everything clear as day, and then all of a sudden it will look like your headlights aren't working anymore and it will go rather dark. Yeah, and then I built an LED ring in them so that I have turn signals built into them. Yeah, honestly, was one of the most complimented things was how unique the headlights look. Got another photo. I also have the charge port on it so that I could plug it in. I plan to rebuild them, but I want to experiment with trying to cut some weight off of them. Either build custom, either reuse the mechanism, but build custom, what do you call it? LED housings behind it, so that I can cut it down. And the other thing I want to do is I want to swap the solenoids in them for like, I found miniature geared motors that have like a screw shaft on them. They're like M4 shafts on them. Really small, super lightweight suckers. And I think I can 3D print pieces for it and turn it into a miniature linear actuator. And the reason to do that is so that I can save some weight. Well, not just save weight, but save power. Because the solenoids in these for the high beams uses about an amp. The battery wasn't fine, but if I need to save weight, using less power means a smaller battery is needed for things. But, and then the other thing I want to do is, instead of the key switch for turning things on and off, I want to push start on it, and I'm going to build my own custom key fob. The other reason for building the custom key fob is because I want to make it fully canopy based, and I'd like to put an actuator on it, and then embed in the carbon fiber a capacitive touch trace, so that all I have to do is touch it, and if it's unlocked it would open. Or on the key fob we'll have a button to open it manually. And then the other thing I picked up is a speech recognition module, and it lets you custom program all sorts of phrases into it, and then you can train it. I got the older generation of it on sale for a rather good price. Even the current version isn't a bad price for what it does. No, because it will actually make it more aerodynamic. The funny thing is, so even the trike as is, how heavy it is, how big of a motor, how big of a battery and everything, that thing's more efficient than my two-wheeler that I stand up on. Like, it's absolutely ridiculous. But no, the canopy will actually bring the drag down. It will give more aerodynamics. Not that it really matters with the motor. Yeah, no worries. Have fun, Keith. Should actually design some circuit boards. Now, these notches. It's a really... Yeah. I always want to do a 0.5 millimeter for this. the left. Oh, on my workbench? Your left. On screen. Which... I'm not sure what you're looking at, because the only thing I see is what I'm doing right now, which is me drawing the outline for the circuit board. Oh, this stuff? These are all the parts that need to go onto the circuit board. Yeah, these are all the parts that have to go on it. So you got ESP-S3, you got an NRF radio, you got the connector for the screen, SD card, connectors for peripherals, there's a haptic motor driver, there's a touch sensor in there. There's a whole host of parts. RS-232. The spider webs are all the wires that need to be drawn. Because they all interlace with each other, so it goes based off of the schematic. Schematic tells it where everything's supposed to link. That's pretty much everything that has to fit in. once this design is done, bill of materials, order parts, and then once things are in place, I can solder and gotta design the 3D prints to hold everything, and then programming. Lots and lots of programming. All of that has to fit on all of that. Now, I already know that this is going to need to be over here. And the reason being is because it's through hole. And if it's over here, it will interfere with the screen fitting. And then the other part that is critical is this connector for the screen. Yep. Well, it is a custom inventory management system. Keyword being custom. I thought I labeled that. It's not TFT. Now that's it. So. There are quite a few, yes. Yeah, there's quite a few. Lots of capacitors and resistors for all sorts of things. And what demo was this? Alright. And let's lock that into place. This corner? The only reason I'm doing that is because the way I'm holding the board is I'm measuring off this edge. So I'm measuring off the edge for the connector and edge there. So this corner matches the corner inside the program. And it's the easiest one to get my veneer calipers on. If the connector was in here, then you could potentially come off this corner, but everything's been measured off of this corner anyway, so all the referencing so the screen has tabs in it to hold the board in place, and then has indents for tabs to fit, to stop it from moving. So everything was referenced off the one spot. Last thing you want to do is change your reference point partway through something, especially with manually trying to measure a circuit board that doesn't have tight tolerances to begin with. Four layers. Wait, what? Wow, that stack up is wrong. Okay, so the copper layers are right. Be curious if that actually affects the 3D model. If it does, then I have to fix that. So this one is finished, and this one is only 2 layers, if I'm not mistaken. Yeah, 1.6. Okay. I just realized I made a mistake on this. This trace right here should come around. or at least go around the one ground pin. Granted, it's still getting good ground contact through there, but I can make it better. Because all your power grounds are along here. Well, there's a power ground there too. Can do this. Just gotta fix this one. Yeah, no worries. Have a good day, Dodgy. Hello, Aaron. Ooh. I assume you've been working for a little while, Aaron. Or did you mean you didn't get the notification that I was streaming? Oh. Actually, I've heard from a bunch of people, not from my channel specifically, but it seems like YouTube's doing a crap job at notifying people of late. So, the thing I wanted to check is... Come in here. Alt 3. Yup, I was afraid that was going to happen. So it's set to be a 4-layer board, but it's making it absurdly thick. Which means I'm gonna have to fix that on the base station as well. The project base station. So base station is supposed to be 1.6. So that fixes that one. Yeah. It's weird. You would think they would set it up so that changing the layer fixes the thickness, but it seems to add the extra layers but not change the thickness. I'm glad I noticed it, because I run into the issue of exporting the 3D files and then realize later that it was wrong. Granted, thankfully this setting doesn't affect the CAD files for fabrication, so it's just purely make it hard for me to oh yeah, I know why. I already fixed it in the other one, but this one needs to be 1.2 millimeters. So that gives you sorry, 0.46. It gives you your 1.6. But I need a 1.2 millimeter board, so 1.2 millimeters. There we go. And now I have to fit everything in a 46 by 100 millimeter board. Yikes. So ideally this needs to be on the edge. Oh, I just realized forgetting something. Because this slots into the screen, it limits my spacing. The original is 46 by 58. Now, if I did this really nicely, this actually extends slightly past the screen, but by a very small amount. If I do it really nicely, I might even be able to fit in some mounting holes for the quick connect light sensor that I want to fit in there. Would make for very easy mounting. If not, it's not hard to work around it. But if I can fit some M2 holes, it'd be great. I think they use M2. It's either M2 or M2.5. But, right. 58 millimeters. And, not mistaken, losing a couple millimeters. 2.4. The fun news is I found out that the one meeting the client kind of wanted me to attend, it's the board meeting. That's not scheduled, well, the in-person one, because they've been doing them virtually since the pandemic. Their first in-person one isn't scheduled until July. So I've got lots of time. I was expecting it to be not this month, but potentially next month. Didn't realize it. I had all the way until July. So I'll definitely be able to get something presentable by then. Make sure. Yep. Okay. Can't put any parts within those zones. These ones, yes. Wish I could say I'd have the ATM done by then, but I won't. And considering I have half the bill of materials done already, that'll save me a lot of time. Now, ideally I position this where the data lines for the screen can flow nicely. Ah. Oh, of course they're backwards. Just my luck. Update that. There we go. Now all the data lines can easily make their way across. There were two others, which is these ones. RSWR. Looks like ideally I'm gonna want them over here. Can move the buzzer as well. Oh, the LED zero is there. No, I'll just leave them. Yeah, I might just leave it then. The main ones I wanted to run nicely at the data lines. But if I can make the screen work with this monstrosity, I'm fairly certain this will work just fine. Radio. That can work. Let's turn these nets off for now. Oh, there's another unlabeled connector. Let's show it on the schematic. Update. Those are going to be next to each other for obvious reasons. Here's our first quick connector. You got touch. Oh, another one that's unlabeled. LED. Show it as well. Save. Update. That should be your haptic motor. There's another quick connector. Oh, that's your battery quick. Let's rename that quick. battery. Actually, don't need the underscore in there. Save that. Update this. And then we have a regular quick connect, which I don't think I have anything at the moment that I'm actually going to use that for. Oh, this is RFID. RFID. Let's fix that while I'm here. That is saved. Update this. Actually, now see, that's not entirely accurate because that reader can do both. Let's change it. That's better. F8. Save. Now this uses I2C, so ideally you place it near these. And ideally you place these one after each other. So that the traces just come straight across. So, anything fun happening for you, Aaron? Ah. Oh, yes, yeah. Yeah, I haven't had a chance to spin one up. That's everything that needs I2C all lined up. This goes like that. Can I get it any closer? Ooh, I can. Oh, nice. Connection to the printer. Thinking would work well here. By putting it there, you could run your SPI connections over to these 3 items and then run them through a inner layer over to the control. Ideally, this ends up on this side of the board. Because the scanner would be this way. I'm waiting for some more movies to come out before I go back to the cinema. And this needs a label. Oh, should actually make the label visible. Part of the reason I want the label visible in the schematic is because I'm going to make a printout of all the schematics. And if it's labeled on here, you want it labeled on the schematic so that you can actually find it. And I'm realizing I need to update it first. I've watched a few movies, some TV shows. Other than that, I enjoy this. Like, I can get wrapped up in it. Plus, I wouldn't necessarily say the project is behind schedule, but I definitely expected to be further along by now, so now that things have kind of fallen in place, I kind of want to ride this train, because I know for myself I can hit highs and lows. So if I'm riding a high, I might as well just power through it and do what I can so that when the low comes, I'm not so stressed about not doing anything. But I don't overexert myself in any of the states that I'm ever in. I've learned the hard way what that does to me. Man, that's probably the biggest I see on this entire board, other than the ESP. And that is to run the RFID reader. is my 5-volt regulator. Got an MCP. That is your haptic motor. Volt regulator. I'm hoping that this power regulator works nicely. Never actually used it before. This is for the touch. This power regulator is both small, has a good amount of current it can give you, and it only costs you $1.30. This is for the haptic. This one is for the buzzer. This is for the scanner. That's for that. There should be one other one. Oh, it's over here. What's this connector for? Oh, debug. Sure. That is for the backlight, which I think is over in this corner. Yes, it is. Realizing a lot of these boards, because how small and compact they are, I'm limiting the labeling that I put on it. Realizing it'd make them a prime candidate for pick and placing. Kind of makes me wish I budgeted for the Lumen PNP. Maybe I'll get it next year. So I'll have probably more boards to do next year for the ATM machine. What's this one for? Oh, it's for I2C. And this one drives the touch. Yeah. This is for the output of the touch. This is for the RFID. This is for the LEDs. This is for the NRF radio. This is for 5-volt power. This is for RFID power. This is for the LDR. Battery is always connected. And because of that, I should probably do this. And just a bunch of capacitors and resistors I need to sort. That goes to I2C. That is for the LED backlight. That is a scanner indicator. Power for the NRF radio. That is for the LED. Power for the LCD. NRF radio. Touch. Five volts. RFID. ESP. Touch. RFID. RFID. LCD. I2C. This is the trigger. Where did I put it? Ah, over here. Enable. That goes over here. Mode is part of the touch. That is for the 3 volt. It's for the buzzer. That one. It's for the scanner. 3 volt. Five volt. RFID. SD code. That is for the LED. This is for 5 volts. for the NRF radio. Touch. Oh, other than PCB stuff, no. I'm watching a few TVs and movies, but nothing fancy. Oh my goodness. Need to wake up. I actually slept decent hours today, but still a little tired. That's what I get for streaming 12 hours. Haptic. 3 volts. Why do I feel like that's backwards? I got that tied to ground. I feel like that's supposed to be tied to positive. So, what I'm looking at here is this trigger to read. I find it a little easier than sending the serial command. Granted, I haven't gotten the serial command to work for it. It's much easier to just pull the I/O line low to trigger a read. But I have a pull-down resistor there. So I want to see if I'm thinking backwards or if I made a mistake in my schematic. But I do believe so it pulls it to ground read, so I do indeed have that resistor going the wrong way. So this should go to power. Now, what I actually could do is tie it to switched power. Not that a 10K resistor is really going to use much power. Okay, that's fixed. And then come back into here and update. Okay, that goes to the scanner over here. This goes to SD card. This is for touch. My goodness, the touch has a lot of parts to it. It might almost be worth just putting the quick connect for this touch sensor. Oh no, they don't sell it as a quick. Oh. They only sell it as a circuit board. And it's got a pad already on it. No. Granted, I could just use a connector with I/O on it. But I'll leave it for now. Having it integrated, I think, makes more sense. Now, if I had a PNP machine, that'd make this a million times easier. And fun. Wow, not that I don't like doing PCB assembly. One day. I will have one eventually. Haptic. Wait. Yep, okay. That goes to the LED. Screen, backlight, pogo, ESP, 5-volt regulator. Last one, 5-volt regulator. No, it just needs to all fit on the circuit board. I wish there was a shortcut to turn stuff off. Eagle had it. It was super handy. So main power is there, so let's put this here. This is backlight control. So you're gonna have 3.3 volts come in here, come around to there. Ground can come up to there. From there, come around to here. Let's run it like this. Run it across, run the trace down. And then there should be more power over here. I think there's one more spot that has power. Right over here. So I can do that. Oh, this is reset. And that is the I/O line. What I can do is either attach it to the LED or the debug connector. What I'm hoping is that let's update my traces. set it for 24. Wow, fantastic, that fits. Okay, that works. Looks like I can go. Yeah, that's 10 mils. Okay. Can I go to 12? Ooh, I can't. Actually, best bet is probably going to be able to do that. Well, the better thing is probably just going to be to do a polygon fill. But for the moment, I'll do that, and then I'll come over here this LED to there to there. Ground can come through here. Ground fill, that is, will come through there. Ground fill can come around through there. Ground fill can come through there to there. This one, I could probably fit like that. Fit like that. And that signal comes back to there. And then this can come right here. That's that. Still hanging out, Darren? Or did your internet die again? Oh, net G. Pad 2. actually. Nope. What size is it making that trace? Oh, 9 mils? Oh, nice. That's fine. I can leave that. That's a big trace. More than big enough for this. And it saves space. For the time being, at least. I can upgrade later. If needed. And now, I think it would be best to move this stuff up. Ah. Here's the scanner. It's for SD code. SD code power is there. So power is gonna come from there. So let's put it like this. Power can come from here, come around to there. Ground can connect to there and come down to here, maybe come down to here. Spy can be on a bottom layer. And this is power when it comes to chip select. So ideally, put it over here. And that way power comes in, comes across, comes to here, comes down to there. Rotate this. Okay, comes down, comes across, comes down to there. And then CS line comes to here. So via to here. and then clock via this one via comes across to this via, and then come up and around to there. This one goes to there. I don't think that pad's used for anything. What's that pad there? An F radio. Pin 7. Oh yeah, pin 7's the no connect. That must be power then, which comes from there. So which means probably move that down, because I have to get power in between here. Although a lot less power, but power needs to come through there. And then might as well just get these traces and vias in place. And I might need a power trace. Power filtering. Here. Power comes in, power comes across. I'll be tempted to switch these around so that ground is over here, because there's a ground connection via there. I think it'd just be nicer. And then that connects that. 3.3 volts comes up and around, down around there. So that leaves one signal line over here. That gets over here. This connector? Which one? I could. But actually, yeah. Because then the 3.3 volts doesn't have to go as far. Yeah. Initially I was thinking, why the heck would I want to rotate it? But you're right, yeah, having power closer would probably work better. Power can come in like that. And then There we go. That's better. So that's that connection. Debug. Don't think it's gonna fit here. No. Yeah. Barely. Not sure if it's worth trying to squeeze it in there. Or if I want to put the reset button there instead. Or I can put put reset here. Yeah, let's try that for now. Think main power here, and then the regulator is right next to it. I don't think this is gonna fit. I really shouldn't be doing the traces while I'm doing this. Should be laying them out before doing the traces. Let's see here. Ground, reset. I2C. because this uses I2C, it's best to be paired near these. Power's there. Power's there. So, best thing to do is put them like this. Yeah, I could do that. Not wrong. Because it would just be... I would just have to mimic the printer connector. Well, this NRF is the version with the external antenna. Actually, has both. It has an external and an onboard antenna. My plan would be to use the external antenna if I needed it. But, you're right, this is using up a lot of board real estate. So, that's 1, 2, 3, 4, 5, 6, 7 pins. How many is the printer using? 8. Well, let's just do the same darn connector, and I'll just have a blanked out pin. It's gonna be the easiest option. Saves me on parts too. So pin 1 can be power. Let's see here. Pin 8 is ground. Okay. Pin 7 is MO. Pin 6 is MI. Pin 5 is SCK. CS not. And CE. Okay. Let's fix the annotation, because I've now thrown it out. Clear, annotate, close, save. Update, save. Much better. Now the better option would be to move it like this. Oh, I just realized I can't see the chat. Hey Keith, you're back. Oh gosh, yeah, no, you're not wrong, Aaron. Moving the NRF is definitely the way to go in this case. Oh, I got this backwards. Because I really don't want to extend the board longer than 100 millimeters. Then I'll really start paying extra for it. No, so originally, Keith, I had the NRF radio attached directly on here. And I'm looking at all the stuff that needs to fit on here. And yeah, it's a squeeze. Might even have to do the buzzer as something that plugs in, to be honest. We'll see. But this is everything that uses I2C. Along with this. It's power control. SCL and SDA are there. SDA. So if I do it like that, I can straight shot it right across. The NRF is its own board. It's a module. So if I do the buzzer as its own thing, I want it on a 2-pin connector. Granted, I'm already using a 2-pin connector, so it wouldn't be much to add it to the BOM to add an extra 2-pin connector. Yeah. Using it for touch, and I think haptic uses a 2-pin. Yeah. So that's everything that uses I2C. Oh no, haptic uses I2C as well. So, where can I fit the haptic? SCL and SDA. It's backwards, okay. So, it's gonna want to be like that. Okay, that's everything that uses I2C. All in a nice little row. Ooh. Oh, I think that's gonna work. Ooh, that's gonna be so nice. If I moved that over, it could fit. Let's put that there. And then trigger can go here. And then LED above it. Actually, this should go above LED because LED has switched power. And this can come. And then more power switching stuff can come over here. Right. That is for the LED line. I can go here. This is for the base station. That touch. Should have a pull-up as well. Annotate, close, save, update. Annotate, clear, re-annotate, close, save, update. That one also belongs down here. This is power for the LED. This is part of here, but it's the easiest option for this. Easiest option is probably going to be to put it here. So it gets its power connection. I can run the trace across. And then this trace can come over to here. And then switched power comes up through here. Power up there. That doesn't need power. Power. Switched power. Unless I rotate these and move that over and then have power come through. Yes, let's do that. I would get it if I had the money for it. I did not budget for such a machine. And I'd either fit it... I technically have space on the workbench here. If I cleaned it up more. But I feel like there's a spot kind of behind me. That I could probably set up a table for it. Yeah, but this budget doesn't have the room to change. The big tool that I budgeted for is a welder. And I need the welder more than I need the PNP machine. But I would. If I had the money, I would totally buy it and live stream everything. You can have a PNP white noise machine. Granted, that'd be a little harder to live stream. Well, harder to run too because of the noise. I'd have to do it almost all exclusively during daytime. Maybe. I'd have to... I think it's the... Oh, the, oh, mind blank. Yes, the vacuum. Thank you. The vacuum, that'd probably make the most noise on it. So, if you can make that quiet, it's probably the motor itself that's making the most noise. You can probably quiet it down a fair bit with a decent enclosure of some sort. Now that I'm not trying to fit power right now, move this around. Well, not power, it was ground that was the issue, and that's why I was putting that on. They do look nice. The whole project looks nice, especially with the capabilities they've been having and the fact that they're using their own machines to build the machines. Means they're validating everything constantly. I'm sure there's still some hobbyistness to it, but For my uses and my price range, it would be great. Oh my gosh. Might actually fit this stuff in place. Holy smoke-a-doodles. Let's see if I can't fit the power regulators in next. So this RFID needs this 5-volt regulator. And I'm thinking fitting them up here. So power comes in and then it's to there. So if I can fit RFID and the 5 volts up there, 3.3 volts down here. And then haptic can probably fit in here. These are all vertical connectors, so they don't need to be on an edge. Everything's vertical. So all the connectors are gonna come in on the back plane. Ah, that's what connects to there. Yeah, so that's the way I want that. And RX, TX, and switched powers there. This side is because this actually allows you to do two RS-232 devices at once. But I'm not using the second one. And they don't sell it as a singleized chip. Well, they probably do, it's just under a different part number. But I tested this one and I know this one works, so it shall be the one I use. Oh, this goes for the trigger. I bet you the silicon inside would not enjoy it. Unless, of course, obviously, the chip is designed for it. Now, all these capacitors. Yeah, I still think I got space for everything. I'm kind of impressed with myself, to be honest. Definitely wouldn't have done it without removing that NRF radio, though. Granted, I'll be really impressed when I actually get all the traces in place. This is probably my most... well... it'd be fairly close, if not the contender, for the most feature-packed board. But it's definitely my most feature-packed in a space-constrained position. Because I've done... I definitely haven't gotten this close in terms of features on a board. And if I have, the boards weren't constrained to be so small, I could make everything a lot larger. The only other board that probably gets close is the Acer's Black. But it doesn't have as many features. So, touch, and then let's do the power. No, Acer's Black is fine the way it is. It's probably the only board I've actually yet to produce for the Acer's lineup. Everything else has gone through a design stage already. Oh, that's the enable. Pin 1 is feedback. That's not right. Feedback is supposed to be connected to the inductor, not the capacitor. The capacitor goes to ground. There we go. Save that. Update this. Yes, I am self-assembling these. I have almost half, if not more than half, of the parts already in stock. It's not worth the extra expense to have them assembled for me. On top of the fact that if I've made a small error and I order 5 of these because I need 5 of them, if I make a small error and miss a trace or hook up a trace wrong or put a pull up where I need a pull down or whatever, then I'm stuck with numerous boards that are wrong. So I'd rather, for almost every prototype I ever do, the first batch I hand assemble. Just, it's going to be harder to do with these because they don't have values on them. So, power comes in through there. Inductor, connect to there. 5 volts comes out through here. Ideally, I don't like the 3.3 volts just sitting there. So that 5 volts needs to come to this. It needs to come all the way around to here. That's a hell of a distance to go. If I did it like that, I move this like this, that means I can get 3.3 volts around, and then these connections, I think, flipped. And that puts 5 volts right there. Puts ground in a good... not bad. Nothing I can't stitch with a bunch of vias. If I move this back to here, that will work. So power comes into there, 5 volts comes out through here, ground 3.3 volts. Yep, that should work. That leaves the 3 volt regulator. This particular board, of all the boards, will probably be fairly straightforward to solder because it's mostly just connectors. And a lot of these capacitors and what do you call it? Resistors are the same value. It's the other boards that'll be more time consuming, because they're so unique. Now, best way to do this is like that, I think. I need to be able to get a trace from 5, 1 to 1. 5, 1 to 1. And then 3.3 volts, and that goes to the power rail, which I will copper fill all the way around, around to there, yeah. And then probably put a trace into here to there. And then power comes in through here to there. Ooh, I have a notification on Twitter. Ah, it's an old tweet. That's so weird. They changed the logo on Twitter home. It's now the meme Doge. But the only thing left to fit is the touch. No, not adding more. Honestly, like, I fully suspect that for the needs, this will last quite a while. Oh, the logos, yeah. Actually, the logos will probably go on the backside, because then nothing else can really be on the backside. Oh yeah, I should show what I got up to. So the other day, I went and got a new computer mouse. So that made a huge difference on how quickly I finished this, but I did turn it into 4 layers, so that there's proper ground for all the power that has to go to the charging. All the traces are in place, and then I can show you the render. I was actually comparing photos online for JLC, and this purple looks fairly darn close to the color they make, which is nice. So fully featured, everything's in place, and what I added is the pinout information for all the different devices on the backside. The only thing I might still add is, so the touch presence on all these is actually linked to I think the MCPs. I don't think they're GPIO based. Well, they might be actually. I'd have to check. They might be GPIO based. In case if they are, then I should do what I did here, which is label the IO pins. And I might still add some labels underneath the MCPs for what the different pins do. But yeah, I figured can't hurt to have reference on the back of it. But I'm hoping I can squeeze the same type of thing. And I did that to both the base station and the printer circuit board. The battery circuit board already has labels on it on the top side, but I'm kind of hoping I can fit the same type of labeling on the bottom side of this for these various items. We'll see how I make out with it. Right, let's see. Touch. What pin does that go to? Goes to a resistor. That goes to pin 3. One, I'm drinking my smoothie fairly slowly right now. Normally I do drink it fairly quickly, but it's a 6-cup smoothie. If you're wondering. So that's why it lasts so long. So from there to there, ground to there. Pin 3 and 4 connected with a 22 nanofarad, which I think is also the one that adjusts sensitivity. Pin 1 goes to pin 3, okay. And then that is power filtering. Cross wire. Pin 5 is power. Pin 1 goes to FET. Pin 1 to pin 1. Pin 3 goes to these. And then pin 6 goes to this. Now, that is backwards. So flip it in schematic. And that way, pin 6, 3.3 volts comes across to there. The smoothie is black cherry ice cream, vanilla yogurt, strawberries, and blueberries, and milk. Where's this resistor go? Huh. Goes from pin 1 to ground. So there's gonna have to be a via in here, which is fine by me. Not like it's got hundreds of milliamps going to it. It is extremely delicious. Oh. Let's see. Ideally, I leave that and have. Because initially I was thinking 3.3 volts would come down. Yeah, so if I do it like that, that'll work a little better, I think. Put that there, move this a little. That way 3.3 volts can come all the way around. Oh. Oh. New IKEA sensor just dropped. The air quality sensor. They have a new version of it. Oh, okay, it's $50 Canadian. I'd be interested to know how better the accuracy is on it, and if they've fixed their particle range on it, because the previous version of the air quality sensor from IKEA, when it goes from yellow to red and whatnot, is way off from recommended values. So by the time it's red, you should have already vacated. Well, if it's still green, you're potentially being exposed to particles that you don't want to be exposed to. Even by the time it's yellow, you should be out of that room until it has a chance to air out. So right. Let's start adding some copper. Let's set the tolerances on this. 8, 8, 8, 30, 31. Switch to millimeters. Fillet 0.5. This one should be switched power. Yeah, cool. I do have a fan going. It's just enough that I can feel it, but it's not on high speed. I assume you can hear it when I'm not talking. Yeah, if I turn it off, it gets like it's already 29. No, it's 29 degrees in here. Oh my god. This summer is gonna suck. Oh, I need to build an exhaust fan for this room. Wow. It's only like... Oh, apparently it's 10 degrees outside. Wow, it's actually warm today. It's been hovering 0. Yes, in Celsius. So, my room has a singular vent, and it's in my ensuite bathroom. And then I've also done added insulation. When I did my room, the main wall I added some sound foam into it, and it's also like 20 something. It's decent. So it's pretty much, I'm now pretty much an isolated capsule. Plus I have my computer. Not running the 3D printer right now. That was running the other day, which is probably why it's still lingering, because it takes a while to bring it back down after that. Could probably open my bathroom window. It just doesn't open very far, so it takes a while for even it to do anything. Like I said, kind of need an exhaust fan. The furnace is probably on. It usually is. But it's set really well. It's kind of set high. We have it on 23, and that's because some of the rooms get absurdly cold. Yeah. I've been wanting to get a thermal camera to figure out where the pockets are. In all honesty, like, so part of the problem is we have fire doors, so all the doors stay closed, so air cannot circulate very well in the house. So we get really bad temperature differentials all throughout the house, basement, everywhere. And there's people living on pretty much every floor but the main floor. So you're trying to keep the people comfortable, which gets difficult very quickly. But if you try to do your standard calculations and tests on the air conditioning system, it all says everything's functioning within parameters. Okay. Still doesn't help the fact that the basement's either really warm or absolutely freezing, and then upstairs is extremely warm. But yeah. There are 7 people in the house. So yeah. If had the money and whatnot, the way I would solve the problem is put in multi-zone mini splits and put cassettes in the rooms so that each room is its own climate. To me, it's more efficient than overrunning the forced air system. Nope, not with the sound foam you can't. I'm also talking somewhat quietly. It may not seem like it, but I am. No. Nope. Oh, yes. Oh gosh, no, I don't let anyone near the damn thing. Absolutely not happening. So, power comes in, goes to a switch, switch it on, power comes to here. You got 3.3 volts, 5 volts going to the RFID. RFID gets its power from here. Wow, that actually fits. Who does it? Oh, leaving out all the important information, are they? That does not need to be. Granted, aviation is one of those highly regulated things. Unless it's a home build, and even with a home build, it's monitored, but you have safe, at least for us, a home build has still has a certification process, and you have to put up custom engraved plaques for things, but yeah, it's safe. That's about it. I always find it interesting when in elevators, even in today's day and time. I know a lot of people are afraid of them. The only thing that freaks me out is, especially if I'm not feeling well, is the motion. But yeah. Ooh, balsa biplane. Ooh. I think my next best bet is to run the 3.3 volt, because that's going to be one of the bigger traces. Actually, I'm curious how this looks. Not bad. Haptic RFID, quick battery, trigger, LED, pogo, NRF, printer, your SD card, scanner, power switch, and your buzzer. Yeah. That looks great. Yeah, these connectors are the wrong type. These are the locking type. I'm not using them. I'm using this type. That's the non-locking. But still accurate. Me too. It's very handy. It will be very handy when I go to design the thing too. So I have to design the scanners next. The actual assembly and start 3D printing stuff. So I use those 3D views to help me do the scans, or the so no, I don't need it, and the reason for that is because the screen has built-in mounts. So when it's slotted in place, the board I'm designing will come out to about here. So the only thing I do kind of want to experiment with is, where did I have it? I thought I had a footprint of the mounts for Adafruit. Let's find. Ooh, they have a right-angled version. That could work. That's what I'm looking at. Yeah, I think these are M2.5. So I want something like this on there, but on the front. I'm wondering if I can put some mounts on my board so that it's sensor. No, it's gonna be too close, I think. So that's how much space? On the top of the screen, that's 5.7. Smoothie is indeed done. 5.7. Oh no, I'm worse. I'm drinking it right out of the blender. But the metal straws, oh, fantastic. I keep the straight one in my jacket pocket, so when I'm out and about, I don't have to use the darn paper straws if I eat out. Plus, it's always funny when they go to give you the straw and you're like, oh, I don't need the straw, and you pull it out and like, oh. Right. I want to see. What's the size on this thing? I usually say. Is it in the guide? Nope, not using that version. Aha, that's what I need. That doesn't look much taller than the actual connectors. And those connectors are really small. Let's see here. Yeah. The one that I've used before is the BH1750. BH1750. How do they compare in pricing? It's cheaper. Environmental. Seems fine. The height of that is 4.6. 4.6, and you have so if I measure 6. Eh, 1.3. I think I could do it because it would only be that one small section that needs the height difference, and it's probably going to be done with clear resin. Well, not clear. I have translucent resin in stock. Apparently, they have a newer one that's supposed to be more clear, but translucent will be more than enough for my use. Right. So all I need is the measurements on this. Oh no, it doesn't tell you the hole size. That's foolish. Is there noise? Let me check my fan speed. Turn it down. Is it picking it up today? Yeah, I can hear the fan. All I hear is the fan, nothing erratic beyond that. Right. So with this, what size are these holes? Ah, crap. I just realized, even if I have the holes, it's not going to stay in place very well on the circuit board because the screws are taller. Yeah, not an M3. It's definitely smaller than that. Let's see. Oh, that's M4. Wrong bucket. That's the bucket I want. It's definitely M2.5, but M2 would work. Kind of gives you a little wiggle room, and the head of the bolt is below the quick connector, so I wouldn't lose any space using it. So I'll do that. So the only thing to do would be to see if I can't set up a grid that matches those holes, and ideally get it as close as I can to the front here. Maybe no, that doesn't work because all that crap's in my way. Double-sided tape? Like, either that or I have the sensor here and it just makes the scanner somewhat larger. Might have to be what I do. Yeah, just gonna leave that for 3D modeling then. Won't be able to fit any. Yeah, because you fit one bolt there, and then you can't get the opposite one over here. And turn back on this one. Alright, the original board ended there, and the screen ends somewhere around here, I think. Yeah. Okay, I'm just gonna leave it. Let's do the 3-volt rail. Nope, that's not gonna work. The reason that's not gonna work is because all the signal traces are gonna come right across there. So. Yeah, I would only need 2 holes, yeah, I'm gonna leave it. 5. Yep. Okay. So. That way ground can come around. Let's power all the way around. No, it's not going to let you. Okay. In all honesty, that's gonna have very little power going through it, and that's a 30mm tray, so not worth fussing over. Reset. Oops, wrong button. There. Now power for the MCP. So it needs 3.3 volts. Well, these are backwards. Now, let's see here. not sure if 10 mils fits. Oh, it does. Okay. Best way. Where does power come in for this? Power comes from there. Okay. If I move this over here, and this there, that, ideally move that like that. That can go straight. This can come here. And then ground can come to there. This, what? Pin 9. Oh, it's the motor driver. Okay. And that means I should be able to get 3.3 volts down in here. Actually, I'm realizing I want this rotated. And then need to make sure that these traces fit. Is on them. And now I can fit a power trace through there. Okay, so let's see here. 24 should be more than enough. None of those pins are used. That's a reset pin. All those are accounted for. I'll move that slightly. That's better. Trying to think how the 3.3 volt rail is gonna work. I'll move this up. Can run the 3.3 volt rail up and around. Oh, that's a ground. that. I'll put stitching in there. It's not handling any current. That could be like that. That gives that power. That gives that power. Ground, reset. That should be my power rail done. Now all I need is a whack load of traces. This. This? That's not done. Well, yes, it looks weird, but it'd be more than enough power. That's a 30 mils wide. And it only gets wider. So, which will maximize losses. Oh, sorry, minimize losses. Not sure if ground's actually going to make its way through there, but I'll put V's in anyways. It's not handling a lot of current there anyways. That's connected. There, that's done. What's this up here? Ground. Oh, there's power here. Signal for that. To there. That's connected. Signals. None of that's connected to anything. We can do that might end up having conflict. Those look like they're too close together. There we go. That's that, and then I've got 2 power traces. There. Chip select. It's a via. And get a via there. Ooh, Discord's busy tonight. Both of those have signals. These have signals on them as well. And signal for that. There's a signal for this one. That one connects to that one, if I'm not mistaken. And then let's alright, all of these. Ooh, that didn't fit. What? Come on. Ground. Three. I'm getting there, almost. RXTX. Reset up and up. Of course. Actually, I'm gonna want space there so that ground can make a complete connection. Well, doesn't hurt that it does. The carrying capacity of ground will be on the bottom plane anyways. Printer interrupt. Or do I have more than one printer interrupt? Got printer interrupt 15. See CS, but I don't see a second printer interrupt. Oh, TP touch panel. Ah, that's the touch panel interrupt. this one is to go over to there. Actually, I think I can do it on the top layer. No, what's this one? LCD reset. Where does that one go? Oh no. I didn't connect that, did I? Oh, I didn't. Glad I was looking for that. Now I know that on the panel, so the way they currently do it, they actually link LCD reset with the touch panel reset. So let's do that. Let's connect those together. Oh, what's it complaining about? Warnings. Via connected to unknown net. Yeah. Oh. Okay, cool. That could connect like that. And that leaves what? Oh no, that's the touch panel interrupt. Oh my goodness. Touch panel interrupt. It's the reset that I need to do. That's a problem. 2 I/O lines short. I could remove the SD detect and do it that way. Don't really need to check that because I would be reading the code anyways, and if the code's not there, then it's not there. And the scanner is going to have the code, so it's going to be my option. That moves that. And the best way to run this, I'm thinking, is to go via green layer, up and around. And then that'll be our first orange layer item. This buzzer is probably going to be on orange, come up and around. That has to go all the way to the end. Let's does that. Oh, that was a small trace. Let's fix that. I really dislike that when you're running traces you can only switch between the red and blue with the hotkeys. Means I have to stop and change the layer manually. Now, where does that go? Up to that corner. If I do it from here, I could stay on green. And then come around here. Let's upgrade these traces. What are these? That's 20. Sure, why not? Never hurts to have good communication lines. Move those for a moment so it lets me run this trace. And then can come up over. That connects that. And need to fix these. And 16. This one's going to be rather simple. Because it comes over like that. Oh, I need to fix these traces. You need a couple vias in here. Come on. Snapping to this. Quit doing that, you silly thing. Place them now, otherwise you'll have difficulty running traces and getting around them later. At least now it forces me to go around it and not have to worry about it as much later. That's ground, that's ground. Ground over there. It's fine. Yeah. Because right now this is going off the board and it will throw an error. Don't need to worry about it, so I can move it. And then what else? This could be green. It comes across. I know buzzer. Could be a via. And then it goes on orange. And it comes across to there. And then RX and TX here. And they can actually go green. And I can come up and around. Go up and around like that, and then this one. This one is one to trigger a reading. That goes to there. Ooh, fancy. Where does this one go? What? should have a connection. Touch internal. There should be diode here. Why is it saying they aren't connected? Let's try highlighting that. Oh, there we go. Okay. So the internal. So that connects that. We got printer interrupt, base sense, touch internal. So this one would have to be on an orange layer. This one could be on green. Yeah. This could be on green. And then that goes all the way over to there. Probably do it on green, come up, over and around. But this one goes all the way to that pogo connector. And this one goes to there. That would have to be on orange. This one can come over to there. This one can follow that. And then I still have to ideally I'd want it on green. But that's not going to work because the I2C is on green down here. So if I put this on green and I2C on orange, and then I can get green up and around through here. Yeah. Oops. So used to highlighting and deleting, so I was instinctively hitting the delete key. And then this one I can change to orange. Oops. There. By doing that, I can take the printer connection on green. Now this one should actually change it to be the same size. Oh no. Oh, that just combined a bunch of nets. Oh. Because they were overlapping and ending up on the same with copper overlapping. That's why I was asking about the change nets. There. And the trigger, where does that one go? I have a feeling I'm gonna want it like that. Maybe. Let's find out. No, it comes over here. So I do want it like this, and then I can come around and up. And it's a larger trace than I want. That can come up and around. This can go like so. Oh, I might actually have to move that. Reset is gonna be a fun one. It's all the way over here, and I have it on green. But I have an orange in my way. If I had this come around, no. If I put another via here, move this down. And I added another via here. And I ran reset to there and back. Almost be ideal to do it on orange potential, but I'll wait. Move this out and go all the way around. And leaves me with like that. And then that's ground. And then that leaves all these controls and the spy, right. Let's rip that up for now. And I need spy. There's one. Might have to go all the way around so that it doesn't interfere with everything else. Like, what have to do. So come around. Like so. And that would get what I need. But the trick will be fitting everything. Around that. Ooh, I can fit it there. Nice. That gives me space to move this up. Because I don't... it'd be in a middle layer. I could put copper in here. But if I could keep it out of those edges, I'll try for now. But it definitely has to stay away from the cutting of that. Now to have these signals for control. And the hard part will be that they have to come over to here. I need at least 3 lines. They're gonna have to be on the orange layer. But I got orange coming down and going across, which blocks it in. If instead of tapping it here, I tap it off over here and come up, it might work. Let's try that. Let's remove that there. I can either tap off here and move orange around this and come up and around, or I can come up over here. But let's do this for now. That is the SPI communication in place. Now, that means I should be able to do that. Now this one is over there. Should definitely move some of these around. That. So now just really, what size are these? 20? Let's make them smaller. That connects those. And then do the next one is haptic power. What else? So you have LED power, scanner power, a second RFID power. Second RFID is all the way up there. Probably gonna need to be on the orange layer. And then these are probably going to have to be these are going to have to be on the orange layer. And they're going to have to go up and around. So let's do them. There's that one. And then these two. Can go up. And around. That's the SD code, which is there. No, quit doing that, you silly thing. No. I'll have to fix that. Come up and around to there. Let's fix this trace up. Now, part of the problem is need access to that. So the easiest way is going to be to come up and over around it. And then that way what I can do is the power selection for that can come around and come across, and then the NRF power is there, so this one can come across. And actually, what I can do is come all the way down here. And then you have this one. And that. And then there's this one. And what's the last one? Oh, the scanner. There. And then let's clean up some traces. Come up like that. Can actually make that like that. That. Actually, what size is that? That's 16, okay. Wonder if I can do that. Yeah, I can. Awesome. Up like that. Move that up. And move that up. What says this? 16? Oh, all these are large. What in the world? Let's rip them up. Let's go to green. That connects like that. Actually, if I darn, there's no way to get it around that. Nope. It's gonna have to go that way. Go to orange. Then these ones can be ripped up as well. And then oh, see you later, Keith. Close to getting this done. Shouldn't be much longer now. Yep. It's going to be fun building the firmware. Initially, there was going to be a meeting with the client. I was expecting like in a month or two. It's actually in July, so I got plenty of time to put some demo code and actually work on the real code for the finalized project. I don't think I'll get the whole thing fully functioning for July, but I can at least get a decent demonstration put together. Yeah, the libraries, almost all of them are custom. Well, at least for my project. For the Oxy's touch panel, some of the libraries we've replaced. Like Ethernet, that one, we're not using the internal Ethernet library. Oh yeah, there's gonna be quite a few of them. It's part of why we switched to Platform IO. Better ability to track the version numbers on things. Oh, I just realized I still have to put these back. Oh no, that's the I2C. Okay, that's fine. Let's put those back up there. I think all the RX TX stuff is in place. Yes, it is. I'll actually move these down. See you later, Keith. Thanks for hanging out. Best of luck with the programming. If I go up with this, and I go up with that, can I go up with that? Just a little more height. What that lets me do is switch the layer on this. Because ideally I don't like it going up, down through the different layers. So let's change that to orange. Oh. Need to select the whole thing. Ouch. There. I'm gonna leave space so that ground can come around it. Not that it really needs it, but you can do it. And then still have to get these in place. But now I can use orange for there. And that should leave this interrupt. Needs to go where? Needs to come to here. What I can do is move that up, and should give me space to come up and around with this interrupt. But let's get these in place. I'm gonna change where they go so that these can fit. And let me move that up a little. Move that over. Okay, so the first one is what? So we got scanner power, RFID 2, NRF, and LED. Nope. Oh right, I have to update this. There we go. That should allow me to do that. And then that leaves this. Needs to be on orange. And we need to give myself some more space. That gets that connected. And then the only thing that should be left is the I2C over here. Oh no, there's a reset line that needs a connection, isn't there? Probably have to put it on the bottom layer, to be honest. Let's see, reset. No, I might be able to get it around. So it needs to go there, and it needs to go there. So if I come down with an orange to here, I can make it work. To there on orange. If I take orange up and around here, if I take it to here, come up and around to here. I got stuck there. But if I move that down, I could do it that way. Let's see. So if I do it like this, and then take do 10. And then we change this to orange. And, well, actually, yeah, so change that to orange. Then I can use this line over here as a connection. Now, do it like this. Orange, and I come down and around, and then I come off of that across and around. Oh, and then over here, I take that like so. And that means I should be able to run to C here. should be able to go up. Oh, need space here. We'll have to come around, come up. That doesn't work. If I went this way, I could move it over here where I have space. And then from there, should be able to do this. And that should be everything. That's pretty much every pin filled. Well, actually, it should be every pin filled. But, let's see. Oh, right, I still need to put the ground plane in. It's gonna throw a whole bunch of warnings otherwise. What is it? Millimeters. 46, I can do it. And millimeters. Ground. On all layers. 30 1mm fillets. Clearance. We're going to increase that, to be honest. We'll see how it turns out first. Might increase, yeah. Let's do that now. Increase the sizing it gives around the cutouts. Knowing that margin should move some of these traces as well. Green. Oh, it's because I set the grid to 1. You know what? This would be better done on the orange layer, so that ground can come through there. Not required, but can't hurt. Build. Right. does that get around? I don't think there's going to be any real way to get that connected. The green layer isn't the important layer anyways for ground. It's just nice to have things connect where they can. Now this. Somewhat open-ended, so if I can get some vias in here. Be good. There. Ideally, you'd not have that like that, but yeah. Now it's less of an antenna, and I could probably fit some vias in here. Yeah, so that can come all the way around, that could go around. That's good, that's good. Let's go to orange. Oh, I got a huge section without anything. Can I fix that? That around. Let's see. Move that up. That gets ground around there, which gets it around there. This stub. Let's get rid of that. Well, that gets a ground in there. Let's see. Don't want it there. I want it to come here. That ensures ground comes in from more than one spot and doesn't turn anything into a potential antenna. And then, how's the copper on the top layer look? Do that. That's better. That's connected. Can I fit a via in here? Ooh, I can. Let's ground for that. That's got a ground there. Probably put some ground in here. That can connect all the way around. Ground through there. Let ground connect between the sections. There. That lets ground get around, and then ground in there. Ground, 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 ground. Oh, that's 3.3 volts. Let's do it like this. Move that over. We can do another layer, so another corner, I mean. Wait, fill. What's this part? Oh, it's a resistor. Okay, yeah, I'm fine. Not having absolute maximum contact. Can I do that? No. Keep them offset then. Doesn't look the nicest, but it makes it functional. Which in this case I think matters more. LED likes to sync power, so oh no, that's 3.3 volts. And let's move that a little. Let's ground around. What is this? This is 20? Okay, let's rip that up. Let's go to 16. This is a signal for the LEDs, so I can get away with making it smaller. Move that slightly. So that goes through, that connects all the way around. And I don't like that. Let's add size 14. Okay, so that connects all the way around. Good ground. This is mostly just a signal ground. Because this pogo connection to the charger is not actually handling current. It's just to ensure that it ensures that the signal is working correctly. Gosh forbid you lose the actual ground you want. Take these both to 12. These are just signals. Pull it to ground to actuate. Ground there, ground via there, ground via there, ground, 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 ground. That's 3.3 volts. Can I squeeze that in? it's gonna let me. No. In that case, rather than leaving that open-ended, we'll do that. And I can do this. That connects that, that connects that. This is a stub. Can we fix that? That connects that to there. There. That gives full connection all the way around. Via there. Via there, via one. Then have a stub there. That's better. Oh, that's annoying. I'm almost done. What I need to do is the design check. And I've been throwing in a whole whack of stitching vias for ground. And I didn't have to put a single... I don't think I put a single trace on the bottom. Not a single trace on the bottom. So the bottom is just going to be ground. Ah, 7 hours. That's actually not bad. That is not bad at all. Why, for someone to x-ray it later and be like, what the heck is that? It's because I would know that I wouldn't do it. Oh, come on. Let me fit a via in here, please. Yes. Can I fit one here? Oh, yes. Oh, please. Yes. Fit one down. No? Now will it fit? Please. Yes. Nice. The only other thing is to add the logos to the bottom, but those won't interfere with anything, so not an immediate priority. Oh, wrong layer. Okay, and let's run this. Ooh, 17 warnings. Oof. Clearance. What? Was that a trace issue? Oh, it was. What? Okay. Doesn't like it down here. What? H unconnected items. Oh, I saw this too, and I meant to run the traces for it. Let's make the traces a little bigger. Oh yeah, power will be fine going around all that. What? Where's that connection go? Ah, okay. That's a simple fix. And then the LED line. Not even sure I can. That might be the one item that ends up on the bottom. Let's see. To go from here to there. If do it on orange, it might work. You crying about me putting something on the bottom layer? Or did something else happen? Don't worry, I found a way around it. Ground. Connected. Put some more vias in. And tools, nope, inspect. No warnings. Wow, what a lot of work. So, go to Alt-3, and that's what we've designed. So, logos, and ideally I'd like to do what I did with the other boards, which is mark all the pins on the backside, pinouts for everything. I think the only one I won't mark pinouts for is the TFT. That'd be a lot of pins to mark, considering like half of them are connected. Oh, and you missed it, Aaron. I forgot to add a pin. There's a reset line for the touch IC, and there's a reset for the display. On the normal version, they've tied them together, so I know they can be tied together. So I've done that, and then I was out of pins on the ESP, so I'm giving up the pin on the SD card that tells you the SD card's in it, because I'm going to be pulling the SD card anyways. So if I don't get a response, well, no card, throw an error. Wow. I don't know, I feel kind of surreal looking at it. Okay, let's add the logos. And then all I need to do after this is get the bill of materials together and order a whack load of parts. Logos. Oh, minimal. I've pretty much bench tested everything and copied working schematics. Oh my gosh, look at all the Fias. Oh man. all these vias here are gonna... I don't know if I'm gonna be able to fit the self-describing stuff. Not even sure if it's worth putting on this board, to be honest. Can I move those vias? Can do that. Should do that. I think the only thing to indicate would be the power on this switch here. Yep. That'll work. There we go. That's better. Okay. Well, I think that marks the end for me. Take a bit of a break. Might do some of the bill of materials tonight. And then a few days, I guess, I will stream some 3D modeling. Or at least me learning how to use a new program. Thank you very much, Aaron. Yeah. Okay. ASAP. So as soon as I figure out the bill of materials, that'll be when I order. Because I'll have a whole whack of stuff. I'll have to order from GLC PCB, AliExpress, Mouser, LCSC. I think that covers it. All the big four that I order from. So I wanna figure out all the cables that I need, because the scanner, the barcode scanner, has this really small cable. I need to buy a larger one, which LCSC has. The haptic motor, I have to buy that from probably Mouser. There's a few other things that will come from Mouser. Some things are cheaper from Mouser, some are cheaper from LCSC. I have to go through my current inventory and see what I already have, because I do have a fair number of parts already. So, yeah. Yep. Well, have a good night. Thanks for hanging out.